circular dichroism spectroscopy. So, what is circular dichroism? Circular dichroism, the differential absorption of left and right-handed circularly polarized light, is a spectroscopic property uniquely sensitive to the conformation of molecules and so has been very widely used in the study of biomolecules. Circular dichroism often provides important information about function and conformation of biomolecules that is not directly available from more conventional spectroscopic techniques such as fluorescence or absorbance spectroscopy. With recent developments in instrumentation, developments in the bioinformatics have made validated circular dichroism spectra, and metadata has also enabled increased interoperability of circular dichroism with other structural biology methodologies, contributing to their use in joint studies of protein structures at various levels of organization. Circular dichroism is often used for protein structure determination, induced structural changes, that is pH, heat and solvent, protein folding and unfolding, mutation in protein sample, ligand binding, structural aspects of nucleic acid, polysaccharides, peptides, hormones, and other molecules. In recent years, circular dichroism studies also used in other structural biology techniques such as X-ray crystallography, neutron scattering, molecular dynamics, NMR spectroscopy, molecular dynamics, and computational modeling due to new developments in circular dichroism data accessibility and bioinformatics softwares. Moving to the working principle, the physical basis of circular dichroism is the utilization of circularly polarized light, and circular dichroism instrument records the unequal absorption of left-handed and right-handed circularly polarized light. Circularly polarized light is obtained by superimposing two plane polarized lights of the same wavelength and amplitude polarized in the two perpendicular planes, but there is a phase difference of 90 degree between them. The schematic representation of right circularly polarized light and left circularly polarized light is given in this slide. So, the polarization of light. The polarization of light is categorized into three categories. These are the unpolarized light, and plane polarized light, and the circularly polarized light. The circularly polarized light is the magnetic field which keeps the oscillating, but the electric field vector changes direction in a rotary motion. Here we have the instrumentation of the circular dichroism spectroscopy, and these are the various spectra absorbed by various protein structures, that is alpha helix, beta sheet, and random coil. Applications of circular dichroism spectra. Applications includes the determination of protein secondary structure. It is the best method for monitoring structural alternations due to pH, temperature, and ionic strength. It gives structural, kinetic, and thermodynamic information about macromolecules. It estimates alpha helix, beta sheet, and random coil configuration. It determines the conformational changes due to protein-protein interaction and protein DNA protein ligand interactions. It measures the folding and unfolding structure state of proteins due to temperature changes, and metal containing proteins can be studied by visible spectroscopy. The advantages of circular dichroism spectroscopy includes um, it is a simple and quick experiment. No extensive preparation is required. Relatively low concentration and amounts of sample is sufficient for CD spectroscopy. Microsecond time of resolution is sufficient. Any size of macromolecule can be determined by using circular dichroism, and it is also useful, which is used for determining the folding characteristics of protein. Circular dichroism also helps to generate proteins on a big scale for therapeutic reasons utilizing a recombinant DNA technology. The limitations of circular dichroism includes certain buffer compound in the sample strongly absorbed in the far UV region and cause interference. Carbohydrates cannot be easily studied using circular dichroism. Oxygen must be completely absent from the system to experiment with 200 nanometer. It does not provide atomic level of structural analysis. It can it can be used only for qualitative analysis of data.